So before moving on to the next part, I am going to summarize all the tools that we have discussed so that you can use them collectively into a single problem set. And I'm also going to introduce the factor of time in these functions so that you can animate them and understand what happens when the simulation runs. So let us first create a circle, then create a line, create a line perpendicular to it, create tangents. Now as we'll move this point C, we'll find the locus of intersection of these tangents. These lines form an angle of 90 degrees, so the point of locus will be a circle known as director circle. So add the locus at the intersection point. Now as I move this point, in this way we can see the point of locus of the intersection of tangents that form an angle 90 degree between them. We can also change the appearance of these lines from here. Draw pattern. In this way our figure looks clear. We can use many tools into a single problem set and visualize things how they actually work. So let me take another example. Let's create some functions. Now I'm going to show you how to use some widgets. So the name of this widget is A. We can also change their name. Now choosing this function. First let me create another slider. Its name is B. So now let me change the functions. And as you can see, as I change the value, the curve changes. Now let me create another function. Suppose it's sin x. Now let me create a tangent at the intersection point of these curves. Now as I change the value of p, as you can see everything changes according to that. So now I'm going to introduce these sliders into the equations of these functions. I'm also going to introduce the factor of time to these functions. Here I change from sin x to plus t. So here t is a global variable of time in the environment of SymPhy which can be used anywhere. So here we have, and we can also change the amplitude with A. Now changing the value of the parabola. Suppose here I add a tangent to that intersection point. Now as we play the simulation, both the curves are moving according to their equations. We can also change their values from these sliders or the amplitude of the curves in such a way. Pause the simulation, and you can change the values through these widgets. These widgets can be very helpful. Now clearing all this. Now first create a function, or let me change it to cos. Now measure the length from this point to this point and name this as L. If I create a body and if I add a joint for fixing it to the background, now if I apply a force at this body at the center 0 comma 0, and the force in x direction is 50L and the force in y direction is also 50L. Now as I play the simulation, the cos function moves and the length also changes. Force is a function of length. As the length changes, the force will also change. We can increase the simulation speed from here. So here I illustrate this with one more example. Create a body at the center. Now create a circle. Move this point. Now create a line parallel to x-axis passing through the center of this circle. Now create a vector joining these 2 points. Now join these 2 points. Now measure the length of these 2 points. Now measure the angle between the 2 lines, between the vector and the line. So let me change the values. Make it as L. Make it as A. So here we have. Now if you want to apply a force at the center, action, apply force at a point. So in this way we can change the force and create our own widget according to our preference. You can also move this point from the keyboard.